Okay. So, we're going to talk about, well, let's actually talk about the MVC stuff here for a few minutes first. Some of you have been exposed to this just this past semester, but how many of you have heard of the phrase design patterns? So several of you have. You've never heard it, old Alex? Were you paying attention to my classes?
You never mentioned it.
Are you sure?
Yeah, which class?
300?
Probably, yeah.
300
All right, so, well, it sounds like you're not alone. So most of you have not heard of design patterns before? Haven't heard of this phrase? Okay, so it's actually something that's going to come up pretty often in job interviews and stuff like that in computer science and in IT, probably to a lesser extent. But design patterns tends to be something that companies, well, just like all technology things, people try to make themselves sound smarter by throwing around buzzwords that actually mean easy things. You know what I mean? So people will say, oh, okay, well, you know, MVC, you know, tell me about your favorite design pattern. We have MVC, we have Singleton, we have the Observer design pattern. There's a whole bunch of design patterns, literally an infinite number of design patterns. Did any of those ring a bell when I said like MVC or Observer or Singleton? Have you heard any of those before? All right, so design patterns in general. This is a proposed good solution, I'll put that in quotes, good solution to a, quote, common problem. That's all a design pattern is. Proposed good solution to a common problem. Okay? They must also have funky names. I don't know if that's an official requirement, but they tend to all have funky names. Okay? This could be almost anything. But we're thinking about these, and we're making this connection is over here when I mentioned that PHP has no MVC. Let's talk about MVC for a few minutes as an example of one of our design patterns. So MVC stands for Model View Controller, okay, which really is meaningless. It doesn't tell us anything about what that thing is, right? Okay, so again, funky names. All right. MVC Model View Controller basically says this. It's a good idea to keep your implementation and your interface in separate files. That's all MVC says. So wherever your logic is for your program, put that in one place. Wherever your design is for your program, put that in another place. Go ahead.
So is that Swift then?
Huh?
Or is that mainly Swift, like iOS apps and stuff?
Everything. I mean, everything. I mean, Xcode support has an implementation of MVC. Android Studio has an implementation of MVC. Ruby on Rails has an implementation of MVC. Through third-party applications, PHP has an implementation of MVC. So MVC is an idea. Okay? It's an idea that it's a good idea when you have user interfaces and you have logic that makes them run. It's a good idea to keep them in two separate files. Because if we intermix them, things get all wonky. You know, too much confusion. We see, you know, we've already talked about HTML. Looks kind of like code, right? It looks programming-esque. So if you take real programming language and you take HTML data representation language and you shove them all together inside of one document, you have a pretty confusing looking document. MVC says that's not the best idea in the world. Keep them separate and your life will be easier. That's what that design pattern says. Okay? So one downside of PHP is it doesn't inherently support MVC. But MVC is provided, so we could say no MVC by default. MVC through third-party, what are called template engines, which then becomes another interesting buzzword. All right, so let's talk about template engines for a second. And I'll also put a link up to the slides on Blackboard as well. All right, so template engines also sound like they would be a difficult thing, right? Sounds like kind of a scary phrase. Anybody know what a template engine is? Something that creates templates. All right. So let's try to connect the dots based on our understanding from back here. So I'm telling you that PHP did not inherently support MVC.
Maybe divides the application logic and the data. The view part of the application and the logic part of the application.
Okay, but
Templates engine works like that.
okay. So the issue here with PHP is that by default, the PHP way of doing things would be to have your HTML and your PHP code in the same file, intermingled with each other. So we step in a third-party solution to this. Okay, so it's called a template engine, but who cares? Each one has a different name, but that's the type of application it is. Just like Microsoft Word is a word processor, a template engine is like a word processor. Or a template engine is to Word as a word. Template engine is, I don't even know how to say it since I can't tell you the name of one of the tools. Let's just pretend I didn't say the whole last like 3 sentences. Let's go with that route. All right, so in any case, the default way of handling things with PHP would be have your PHP code and your HTML code in the same file. We're going to say that's a bad idea because as your application, as your website starts getting complex, that file is going to be very difficult to maintain. So now we need this tool to help alleviate that problem. How do we separate our PHP from our HTML if the PHP way of doing things is to have them in the same file? Okay? That's where our template engine comes in. What our template engine lets us do is it allows us to programmatically create a PHP variable for a template. And then we can add values to that variable. And those values then plug into the template on another screen. Let me kind of give you an example of this. So a template engine would maintain a set of HTML templates that largely contain native HTML code, but will also have placeholders for dynamic values to be injected at runtime. So you mean the placeholder stands for which of the letters? Is that what you're asking?
The placeholders are similar to the model, the data holding objects in the template engine.
Well, let's see. The controller would be the PHP code. The model would be the template, not the placeholders themselves, but the template. And then the view would be the connection between them. But I would say that's not important. It's not important to try to understand what letter goes with which part. We want to understand ideas. So, the idea here is in order to get these guys separated, what we would have is we'd have a template file that might have a line in it that says something like this. Before we had, hello world inside of a h1 tag, right? But maybe instead of hello world, maybe we put in a placeholder. Maybe something looks like that. Okay, so some like funky start and end tag things for a variable called current user. And then inside of PHP, we would have a variable, something like that. And then we can say something like t.inject mic for variable current user, something like that. And that would send the value mic in for the placeholder current user, so that at runtime, this template would replace that guy with Mike. So a majority of our HTML code is going to be sitting inside of the template. And only the parts of it that ever change will be referenced inside of the PHP code. Make sense? That's what template engines are. Just a way of rewriting HTML at runtime. Okay, so MVC, fancy way of saying keep your interface and your implementation separate. Template engine, fancy way of saying let's throw all our HTML into one file and just give you some sort of convenient way of getting your values in there that you want to replace at runtime. Design pattern, fancy way of saying, hey, there's often some pretty good solutions to common problems. Why don't we give them a funky name? Okay? A couple other design patterns we will talk about eventually when it makes sense for us here, but right now, let's just leave it at MVC. Okay, so when we were talking about PHP on Apache, we said that PHP was Apache was old and stable, high performance, with old and very web-centric programming language that didn't natively support MVC, but can we all agree that that's not really a problem? Because it does have support for MVC. Otherwise, if it didn't, PHP would have ended up dying, clearly. PHP is still among the most popular web-only programming languages. Mostly because it was specifically designed for the web. Most of these other languages were designed for something else first, and then kind of turned towards the web. And that kind of started with this next guy in line, the Ruby on Rails dude here. So let's talk about this. So remember, before we took a break, we were mentioning that we have PHP on Apache, so I rewrote these guys out, right? So PHP is the language, Apache is the web server. Ruby is the language, Rails is the web server. Python's the language, Flask is the web server. JavaScript's the language, Node is the web server. All right, so how many of you have heard of Ruby on Rails? It's probably one of the more popular buzzwords, at least, right? Okay, so whether you know anything about it at all, you've probably heard of. Chances are you've never heard anybody say I'm a Ruby programmer. It's always either I'm a Ruby on Rails programmer or I'm a Rails developer. The cool kids just say Rails. Makes them sound important, right? Okay, so what do we know about Ruby on Rails? Huh? Okay. Yes, but the opposite of that. It's actually pretty old. Newer than PHP, but older than the other ones. Yeah, Ruby on Rails is a fairly old technology, relatively speaking. I mean, none of them are like as old as me, but they're old, relatively speaking. So what else do we know? Could we agree that, first of all, I've written these guys out in chronological order, as you might guess now that we're kind of heading down that path. Would you say that when new technologies come out, more often than not, those technologies come out because they're trying to improve upon something that was wrong with the older technology, right? Okay, So more than likely, Ruby on Rails was trying to improve upon a weakness from PHP. Now, our most obvious weakness on the PHP technology is that MVC weakness. It's now been fixed by having third-party places come in. But before that happened, one of the major goals of Ruby on Rails was to fix that MVC problem. There's also a secondary issue that was needing to be fixed there, and this is actually very related to the IT field. So if we come back into this model here, when we talk about PHP on Apache, that guy, in that event, that web server is Apache. Well, Apache isn't a simple web server to install. It requires that you have a web server physically available to you, first of all. Okay, so there's a whole IT side to this problem. Before you even start programming in PHP, you have to have your development environment set up. That means you have to find a physical machine that you can run Apache on. You have to install Apache on that machine. You have to install the PHP module for Apache on that machine. Then you actually have to write your application and either upload it to that machine or do your development right on that machine. Okay? That's just to be able to do development. As soon as you're ready to actually put that out on the internet so it's in the front of the real world, now you need to find a way to get your machine a static IP address and get it on the internet somehow. Okay, so there's a lot of hurdles that you have to jump over in order to get a PHP on Apache environment set up that have nothing to do with programming. So most of your hurdles have to do with network infrastructure and server admins and stuff like that. Now, the good news is we have a lot of different web hosts that exist out there now. So for instance, you can go to GoDaddy.com or something like that, sign up for an account, and you can have, for $5 a month, you can have a PHP-enabled, Apache-based web server up and running in 5 minutes. No harm, no foul. So that really isn't a problem anymore. So one of the things, PHP's been pretty lucky that the internet has grown at a pace, that the rest of the infrastructure has solved some of its internal problems. Kind of make sense? So PHP itself kind of relied on Apache. Therefore, if it's going to be widely adopted, it relies on people having easy access to servers running Apache. Not everybody had easy access to servers running Apache in the early days of the internet. Well, now it's pretty easy. You can even get free Apache-based web hosting if you're willing to have them put ads or all around your web page up there. So with that in mind, that problem kind of went away, but certainly was a problem back then. Okay? Similarly, MVC was a problem back then. Would you agree that in the early days of web development, web pages were less complex than they are today? Sure. I mean, web pages keep getting more and more complex. The types of experiences that we're delivering over a web page now is more complex than it's ever been. Okay? So if we can imagine having all your code and all your interface in one file for a highly, highly complex page like, for instance, MSN.com today, that's going to be a pretty hard to manage web page. Pretty hard to manage PHP document. Okay? So we're going to say PHP had its weaknesses that have since been cleared up. Not entirely. We're going to still have to have an argument on what makes the right technology for us. But things that were clear weaknesses at the time that Ruby came onto the scene are not as weak anymore. So Ruby solved two problems for us from a developer perspective. The first problem it solved is Ruby has built-in MVC. Built-in MVC and comes with its own built-in web server. So you don't have to set up any sort of server infrastructure. You don't have to worry about MVC. You literally just grab the Ruby framework and start writing your application. And Ruby does the rest. Now, you do have to do things the Ruby way. So with that MVC is included thing, comes with it the, a very specialized directory structure that Ruby forces you into and says, okay, this is where you put your interfaces. This is where you put your code behinds, your controllers. This is where you put these different things so that they can all talk to each other. All right, so Ruby forces you into a directory structure. You have to do it the Ruby way, but you don't have to set up your own server environment. You don't have to configure your own web server. All that stuff's just done for you. So Ruby really lets you focus on development right out of the gates rather than on all the extra setup. Okay? So Ruby built-in MVC comes with its own built-in web server. Includes gem library. So the Ruby gem library is a way of third-party plugins for Ruby to be distributed. So all within Ruby's ecosystem, you can use gem to install extra things that might enhance your Ruby-based web page. Make sense? Okay, but still very web-centric. Very web-centric. So these first two guys here, PHP, we can make the argument this guy has tons and tons and tons of tools available today because it's been around for so long. Tons of code examples. So these are positives for it, right? If you're looking at how to do something in PHP, chances are you can, with a Google search, find examples pretty quick because it's been around for a while and people have been doing stuff with PHP for a while. And with third-party plugins, you can, you get the comforts of modern development, if that makes sense. Ruby on Rails, but then again, PHP is also very web-centric. So it's designed to deliver web pages to web browsers. Okay? Ruby has a lot of stuff built in, so some of those choices are taken away from you. Very integrated. So almost think about Ruby on Rails as being almost the Apple approach to web development. Fine, with their gems library, you get to use some third-party plugins, but if you want to do MVC, which you have to do MVC, that's the thing now. It sounds like a weird thing to say, but that's what we do. Our interfaces are important, and they get complex now, so we need to separate the two. So the way to do that is MVC. It started 15 years ago, and it's still there today. But the idea is that with Ruby, if you're going to do MVC, you do it the Ruby way. No choice. It's the Ruby way of doing MVC. Third-party plugins all have to do things the Ruby way as well. So some of these plugins are fairly limited on what they can pull off. Okay? So it's a very integrated ecosystem. Everything just kind of works together because it's all very much like the Apple ecosystem, right? If you're an iPhone user and you have an Apple TV and you have an Apple Watch, all your stuff knows how to talk to each other pretty seamlessly. Okay? But if you have an Android phone and you get an Apple Watch and an Apple TV, you're not going to have as good of a end user experience. Make sense? Okay. Out of curiosity, how many of you are iPhone users in here? And the rest of you are Android users? So we have 2.5 Android users and the rest are iPhone users? So you were iPhone or Android?
Android.
Oh, so that was the half. It was one of these. Poor voter turnout. Okay, why Android?
That was my first one given by my father. So
Have you?
I like open source.
Okay, yeah. I mean, fair enough.
That's what I prefer.
Yeah, I wouldn't argue either way. I mean, I've used iPhone for a long time, but I write software for Android too.
Yeah.
So,
Still, I use Linux operating system, and coming to the databases, MySQL and SQL,
mhm.
and into the NoSQL things, MongoDB, and I have gone through a couple of certifications in MongoDB too.
Okay,
I just pretty like to go with open source things. It's good.
okay.
That's
But
my
you've done pretty much only web stuff with the MongoDB, right? Okay, because that's, I mean, so that's going to fall into a similar category as this is Mongo. Essentially, what MongoDB is, for those of you who are familiar with it, is think about what we're talking about here with web frameworks. MongoDB is effectively a database framework. How does a language talk to a database very conveniently, so that you don't have to talk in this? So for those of you who had like a Professor Wall's database class, and you're writing all these SQL queries and stuff like that, that's fine. MongoDB abstracts that, so you just tell it what you want it to do, and it does all that magic under the hood. But it's very web-centric. So it's MongoDB talking to a PostgreSQL or a MySQL database, more than likely, and then a web front end. So you're staying in this world of web, where kind of the path we're leading down here is web is part of our world in our application, but it's not the entire world. And those are things that we're going to have to consider.
Still, we can connect the plugins with Nodejs along with MongoDB.
Sure, yep, certainly can.
That's a good idea.
Yep. But those are things that came from saying, okay, well, here's a cool technology. How can we expose this technology to other things, right? That's what's happened with all these things. That's what we're talking about right here. PHP was a good technology. How do we have it keep up with the Joneses? How do we give it the features it needs to still do all the things it used to do really well, but have the couple things that didn't do so well kind of stick with us? Oh. Oh, here we are. Okay, so let's talk about Python on Flask. My guess is that most of you have not heard of Flask, but most of you probably have at least heard of Python. Okay, so Python is a programming language. What do we know about Python? Who made it popular? Before that. Indirectly, Microsoft made Python popular. Why? Because Google didn't like Microsoft. Google became a Python shop. So Google software development infrastructure is largely, at least internally, Java and Python based. So in the very early days of Google, it was Python. Then they became a Java shop as well. And now more recently, they've started introducing some of their own languages like Go. They have their own Google-based language, which is, I guess, akin to Apple's Swift language. But in any case, Python is a loosely typed, webby. Actually, webby is probably not the right even phrase because Python was not written with web in mind. Okay? It was written as a data manipulation scripting language for doing data science, big value type stuff, things like search engines, things that search engines do, which is why Google had adopted it. But then it became very popular for a couple different reasons. Well, one, Google was using it, so it's popular, right? Google's one of the cool kids. It's an open source based language, so it had a lot of kind of open source support. It had the whole anti-Microsoft world. It had the whole anti-Apple world. So that's the when I ask why do you choose Android over iOS or something like that, those are the only answers that make sense, right? I like open source. I it's to say one is better than the other isn't fair because they're based on such different worldviews. Google has a completely different worldview than Apple has, which has a completely different worldview than Microsoft has, which has a completely different worldview than the rest of us. is the is I guess the punchline. So it's almost like it's like the political candidates, right? You're deciding which of those three big guys you have the most in common with. We're all not going to like something that some of them do, right? But what do you have the most in common with? And that's kind of the ecosystem you jump on. And then that ecosystem then dictates the rest of your ecosystems. All right, so for instance, it wouldn't make any sense for me to have an Apple Watch but have an Android phone. I wouldn't have any user experience. The watch won't work without an iPhone. So the people who want an Apple Watch but don't have an iPhone complain that, oh, well, why do I need an iPhone? Well, because Apple made both of them. They want you to give them twice the money. Give us all your money and you can have a watch and a phone, right? That's how it works. So it's these ecosystems that drive us. So we tend to all collect technology within under the same umbrella, right? So Python, being a scripting language that was adopted by kind of a public-facing, cool kid, open source type of phenomenon, is the kind of the Google movement, if you will, instantly made it kind of famous. So you had a whole bunch of people who were saying, oh, I want to write Python code. Then, at odds with that was this whole up-and-coming world of web developers. Everybody and their brother wants to be a web developer and write web pages and make zillions of dollars doing custom development and work at home and don't have to go and answer to a boss and all this other stuff, right? Okay, so all of a sudden now you have, okay, well, I have a skill set in this language. Now my argument is all languages are the same. So it doesn't matter where your skill set is. Programming as a skill set can be applied to any of these technologies. You just have to learn the little idiosyncrasies of that technology. What's weird about it? How's it like what you're used to? How's it different than what you're used to? Then you practice with it for a couple of days and all of a sudden everything just starts making some sense, right? The programming as a skill set is the important part. Okay, but there's a perception that, okay, well, I know Python, but I need to become a web developer because I don't want to have to answer to the boss. So how do I make this skill set compatible with this skill set? Well, that's where a product like Flask comes in. So Flask is to Python as Rails is to Ruby. Flask is its built-in web server. Okay, so this is called actually, it's not fair to say built-in. Flask is a third-party product. So third-party companion web server, MVC, well, let's just say template engines, because you have options, multiple options for template engines. Database, frameworks, etc. So Python became kind of this a la carte technology where you can pull off all the web stuff that the Ruby on Rails guys were getting, but you can do it in more of an open source, open world, where it's like, okay, well, I'm going to take the Python language, and here's 4 different template engines that I could choose, each of them competing for my heart. All right, and you're going to pick the one that you think is the best fit for you. So my particular favorite for Python is one called Jinja, just because I like the name Jinja, kind of like ninja, but it's Jinja. So it's fun to say, so that's why I like it. There's another one called Jade. But in any case, you pick your favorite template engine. Bottom line is template engines can only be so complex because there's not a whole lot to them. They're basically text files that allow you to overwrite certain values in them. There's not a whole lot to them. But tons and tons of third-party things, and they have a package manager called pip. That's the Python package manager. Just like Ruby had their gem library. That was their package manager. And PHP doesn't really have one built in. There's several kind of PHP module repositories out there, but let's just say it didn't have an official one. Okay, so any questions on the high level of Python, Flask type stuff? Solving pretty much the same problem. You get everything you got out of Ruby, except you're using Python as the development language. And things are now based on choice rather than forcing you into the language itself. Ruby, you had to do things the Ruby way, which has the advantage of maybe certain things just work. You didn't have to configure them. But had the disadvantage of maybe certain technologies weren't available until Ruby decided that it could be available. Okay, that's really the Apple world, right? In general, the Apple ecosystem. It's Apple's way or the highway. It's also the Microsoft ecosystem. It's one of the downsides. We don't have the .NET architecture on here, but that's a kind of a big problem with that. Is I mentioned earlier that if you make the decision to jump on one Microsoft technology, you've pretty much bought into the entire ecosystem for that project. And that's not a bad thing, but it is a thing. You've locked yourself into the Microsoft way of doing all sorts of different things. And what that often means is that you don't necessarily have access to the latest, greatest tech. And it's not because Microsoft isn't on top of things. It's because their product line, with their web development and front-end development is through a tool called Visual Studio, is a very integrated tool. So in order for them to bring in the newest, latest, greatest tech, would require them to kind of incorporate it into that tool, and that's not something that they just do willy-nilly, especially when you have a technology that sounds cool on paper, but you kind of have to sit back and watch and see if it actually gets widely adopted. How many things have we seen that kind of come out the gates fast, seem really cool, and then all of a sudden they're nothing, right? So that is a downside of .NET, is that you don't necessarily get the latest, greatest stuff. Plus side of .NET, though, we're talking about the flip side of it, is the programming languages you're using for .NET would be, let's call it arguably the more powerful programming languages, because they're not your web-based languages, which aren't necessarily weak programming languages, but they are, it's like the difference between maybe like a big pickup truck and like a small sedan driving in the snow. They're both going to get you from point A to point B, but sometimes that big pickup truck does come in handy, right? Other times you kind of appreciate the fuel economy of the sedan, and it's actually the better choice. But when push comes to shove, you're willing to trade the fuel economy to be able to get out of the snowdrift. Okay, so our robust native languages like C#, Java to maybe a lesser extent, but still up there, Objective-C, Swift, C, C++, these are all higher powered. These would be more like the pickup trucks than your Python and your Ruby and your PHP, which would be more like your sedans. Okay? Most of the time they're equivalents, but sometimes having that extra horsepower does help. Now, having said that, if you are integrating a web experience with a desktop experience and a mobile experience, and your desktop experience happens to be Windows and your mobile experience happens to be Windows Phone, and your web browser or your web experience happens to be supported by Internet Information Server, well, Microsoft might be a very good choice. We've probably heard these phrases that some places are Microsoft shops. Some places are, actually probably most places are not Apple shops. Most places are either Microsoft shops or Unix shops in the world of web. So your web server really dictates probably the rest of the technology that you have. Okay, so last guy here on the list, Node.js. So we've probably all at least heard of Node.js. Whether you know anything about it, it's kind of like the newest cool kid. So if you've gone to any websites, and everybody who is trying to learn new technologies wants to learn Node. What can you tell me about Node.js? Anybody who's heard of it or has heard any buzzwords or whatever? Anybody got anything? Well, first of all here, notice that I said it's JavaScript on Node. Now let's go back over to this guy here, this slide, where we were talking about our web server talking to our web browser, where our web server always spits out HTML, CSS, and JavaScript 100% of the time. All right? I might be quieting down a little bit. My throat's starting to kill me, so I'll be fine. I've been sick for like 2 weeks, so I'm just getting over it. So I'm usually a pretty strong strength, so your ears would be hurting by now. In any case, we've mentioned that your web server spits out HTML, CSS, and JavaScript to your web browser. And we mentioned that because JavaScript is our dynamic language. It's the real programming language that lives on the front end, this guy. So front end, client side, web browser, those are all synonyms. They all mean the same thing. So when we have dynamic stuff happening inside of our web browser, the guy who's doing that is a JavaScript technology. Okay? Now, we've heard about a lot of those JavaScript technologies. Let me just throw some of that out here before. So let's call them JavaScript buzzwords. Okay, so we've heard of JavaScript, right? Okay, not so cool. What about Ajax? Heard of Ajax before? All right. How about jQuery? About Angular? How about React? All right, so old school, a little bit newer school, a little bit newer school, a little bit newer school, kind of about the same school. These guys are kind of competitors. What's the difference between these guys? Specifically, these guys here. Forget about JavaScript. JavaScript's our base. So, several of you said you've heard of Ajax. What's Ajax? What problem does Ajax solve? Not the stuff you put down the drains. I'm talking about the programming, techie, typey thingy.
Consider any web page, there is a particular division of a page to be reloaded with the server data.
Okay.
Submit some data. So the particular division of the web page will be reloaded with the data pushed by the server.
Okay.
That's
So
the dynamic call goes to the server and get back the data requested by the submission. Depends on the other division of the web page. So that's the exact problem solved by the Ajax.
So the problem is, before Ajax, if you had, so let's use a Wisconsin-based example, right? So you're trying to keep up on the Packers score next year, next year's Packers score, and you're on the web page. We're accustomed to seeing the scores change in real time, right? As you're sitting there, all of a sudden the score just flips. This year, usually it was the other team's score goes up, right? Well, you're a Broncos fan, aren't you? So you're like ecstatic right now. Yeah. I don't mind the Broncos. I like Peyton, but it's been all downhill for the Packers since we played the Broncos. I was in. Remember, you were in my class last semester. No, I was there the week before. I was in. This was when the Packers were 6-0. And the Broncos were 6-0. I was in Colorado over fall break with my wife, and so I got pictures in front of the stadium, like, oh yeah, Broncos, get off the tracks when the train's coming through. Well, then we got our ass handed to us. It was just all downhill from there. I think we went on like a 4-game losing streak or something. That was pretty funny. But hey, what are you gonna do? Should be a good Super Bowl, I think. I think we have 2 pretty good teams in there. Yeah. Well, so typically defense trumps. So we'll see. So in any case, we're watching the sports scores, right? So we're watching the sports scores. We expect by today's standards that the score updates automatically. Well, historically, before we had technologies like Ajax, that would not be the case. You would have had to hit refresh. Or you could have had an automated refresh built into the page, where the page, JavaScript would tell the page to go ahead and reload itself, but it would still be the entire page reloading to get you the updated score. When really all we want is for the score to update, that part of the screen. So Ajax solved the problem of allowing individual parts of a page to update their information without having to reload the entire page. That's it. Something we take for granted today, right? Okay, but that was a major problem not that long ago. Okay, so that's Ajax. How many of you have heard of jQuery? Okay, what's jQuery? Problem does that solve?
Compared to writing code in JavaScript, writing in jQuery is little bit easy. Instead of writing document.getElement by ID in a particular page of the JavaScript code, you can tag that immediately $10 in the dot. So it will the developer friendly.
Okay. So jQuery is the MongoDB for talking to the document object for the web page.
I mean, in perspective of developer, I'm saying the amount of code written is.
Mm-hmm. Well, so you've used MongoDB. So the reason you use MongoDB instead of talking to the database directly is because MongoDB abstracts a lot of the stuff, the calls you need to make to the database. It makes it easier for you to write those things. Same thing is true with jQuery. With if you write JavaScript directly and you need to update parts of the web page, it's kind of convoluted. JavaScript operates off this object called the document object, and that is it's JavaScript's reference to the current web page that's being displayed on the screen. So you can manipulate that directly, or you could use jQuery, which kind of has some libraries built into it for manipulating it more conveniently. You're still doing the same thing. What's actually happening under the hood is the same thing. But from a programmer's perspective, you're able to manipulate that document object more conveniently. Just like you can talk to a database more conveniently with MongoDB. Okay? Why would you want to manipulate the document object of a web page? Why would we ever do that? The document object of a web page is the web page. So if we think about this from like an object-oriented programming perspective, okay, we're going to say the current web page on the screen is contained in this object that I've named document. Okay? If I'm going to manipulate parts of this document object, that means that I'm manipulating the web page. Why would we ever want to manipulate a web page? So the web page changes. Isn't that what Ajax did?
Yeah, it did the particular location of the page.
So does jQuery pretty much do everything that Ajax did and then a little bit more? So we said, hey, before we were just updating little parts of the pages. We're just going to make this one little spot live. That's Ajax. Ajax says, make the sports score. This guy will update. He's going to dial home and get the information without having to reload the whole page. Then all of a sudden we decided, you know what? Now that our internet's getting faster and our web pages are getting more complex, and we're trying to deliver experiences through the web that are less like web experiences and more like desktop application experiences. That's definitely a truth today, right? There's more and more examples of, web pages basically being full-fledged applications. It would be helpful if we didn't have just the ability to change little tiny portions, but if I can change anything. Have the web page reorganize, change itself, reorder things in real time without having to reload the whole page, just by me manipulating the current document object. So jQuery is Ajax on steroids. It's what it is. It's an evolution of that technology. All right, well, what about Angular? What does Angular let us do? And who made Angular? So Google made Angular. And then React is Angular's competitor. Do you know who made React? Twitter and Facebook. React is a Twitter and Facebook technology. So Angular is Google's internal technology for doing something. React is Twitter and Facebook's internal technology. It was a partnership of some sort for doing something. And what was that something? Is how do we do jQuery better? So Angular is Google's take on jQuery on steroids. React is Facebook and Twitter's take on jQuery on steroids. And each one has their pros and cons, but really Angular and React are both modern buzzwords. If anything, maybe React has a little bit more hype right now, but Angular has been around a little bit longer. But they're both newish technologies within the last couple of years. Okay? But the punchline here is every single thing that you see on the screen right here is a front-end technology 100% based on JavaScript. It's so easy for us to look at these and say, oh, well, we're looking at 5 different technologies here. Ajax, jQuery, Angular, and React, every one of those is just a JavaScript library. Somebody sat down and said, you know what? This is what can be accomplished with JavaScript. So if we had a really talented developer come in and write a bunch of stuff, they could do this. Or we could write a whole bunch of the stuff for them, give it a funky name, and then they can just use our code to do it for themselves. That's all they are. These are JavaScript libraries. It's not even a new technology. It's just a library in a language that's been around since the beginning of the internet. Okay? So these are all front-end technologies that are all heavily reliant on JavaScript. Why? Because JavaScript is our front-end programming language. If we're going to do dynamic stuff on a web page, if we're going to make that web page natively do dynamic things, it's got to be in JavaScript. Historically, we could have said stuff like Flash, but that's not native. That's requiring a plugin and stuff like that on the browser. We can also more recently say something with like HTML5 that technically is native, so maybe the area is getting a little bit blurred now. But HTML5 is closer to a programming language, but JavaScript would still be, I think it's still fair what I'm saying, that JavaScript is the way to dynamically do stuff on the front end, on the web page. Okay, so that means anything that's going to happen on the front end that's going to be dynamic has to be based on JavaScript. Or we have to just reinvent what the web means. And that wasn't always the case. In the very beginning of the internet, there was a competition. JavaScript wasn't the only kid in town. You know what JavaScript's competition was in the early days of the internet? Your browsers today are technically still compatible with it. It's called VBScript. VBScript, Microsoft technology. What happened to VBScript? Well, once they got the crap kicked out of them, and they lost the war, and it wasn't that VBScript sucked. It's just there was 2 technologies. One of them had to win, right? So JavaScript just had a larger adoption rate. VBScript then morphed into something else. It went from front end to the back end. And when it moved to the back end, it renamed itself? What did it call itself? So VBScript was a scripting language, programming language. It's called ASP. Not .NET yet, Just ASP. Just ASP. Years later, ASP.NET came to be. Well, the .NET framework came to be, so ASP within the .NET framework was called ASP.NET. So that actually takes us down another little rabbit hole here. Back-end tech. So we have a couple of different flavors of back-end technology. Okay? We have embedded languages. So these would be PHP, ASP, JSP. How many of you have heard of JSP before? Okay. What's JSP? Okay. I like everything you said except the front end part. Java Server Pages is a back-end technology, not front end. This is all stuff that lives on the server side. Front end is HTML, CSS, and JavaScript all day long. Okay? If you're going to have Java running out of the front end, it would launch out of a what? What's Java launching out of a web browser? What's that technology called? It's called an applet. Java applets. So that would be a front-end Java technology, pretty similar to Flash. So you need a plugin for Flash to run in a web browser. You have to have Java installed to your machine in order for a Java application to launch out of a web browser. But it's not the web browser running it. It's Java, the Java virtual machine on your computer running that Java application. But that's all front-end. Here we're talking about back-end technologies. Okay? So these are three competitors. This is Microsoft. ASP is Microsoft's server pages. Active server pages is what ASP stands for. This is Sun Microsystems product, now Oracle. So this is Java server pages. And PHP would be everybody else's back-end server product. So this is PHP. These are programming languages that are embedded within an HTML document. Okay, these are embedded technologies. So these are anti-MVC, pre-MVC technologies. Okay, so these guys are embedded within a web page that then get processed, pre-processed by the web server. So it's going to be out over here. So this web server, before it can ultimately serve HTML, CSS, and JavaScript, it has to run whatever you requested through some application. So if you requested a JSP page, it's going to run it through the Java interpreter to process that JSP page. If it's a PHP page, it's going to run it through the PHP module. If it's an ASP page, it's going to run it through the ASP module, or more modernly, it'll be the .NET component architecture. Okay, so those are all embedded technologies. And ASP is dead as an embedded technology, at least in its original form. ASP is dead. JSP technically still exists, but it's not heavily used. Okay, the people who are going to use it it's going to be a pretty similar situation to our COBOL world. You know, places that adopted this technology and had a lot of stuff done in that technology, it's often more cost effective to continue to maintain what's already there than to convert it to something else. My wife's a COBOL programmer for Western Illinois University, where I used to teach, and she works remotely for the last 10 years since I've been here. And, you know, they have thousands and thousands of programs written in COBOL from years and years ago that, in hindsight, had they just all the money they've spent to maintain it since she's been working there. So she's been working there for, I guess, almost 17 years. If you think about it, and she's one of like 40 developers there. It's ridiculous. But if you look at the amount of money they've spent over 17 years, just since she's been there, they've been spending it since before that. Maintaining that, they could have easily, several times over, upgraded it, right, to something more modern. But the difference is that, especially when you deal with state schools and budgets and things like that, they couldn't afford to do it at once. They can afford the slow death of paying the developers to continue to maintain it each year. Barely. We're talking about Illinois here, so they don't technically have a budget right now. But punchline is that unfortunately this is what happens to technology sometimes. Because of the way things get paid for, the right tool isn't used for the job. So I don't think COBOL was never designed to be a web language. Okay? COBOL is probably our most successful business language in history. It was built specifically for writing business applications, and it did that very well. Well, then you had the internet was born, so you had to change. Just like we're not riding horseback anymore because we have interstates and stuff like that, and our horses would get hit by cars. it would be bad. Okay, so kind of like that, but the difference is that instead of like in real life where people still do have horses and they ride them not on the interstates, COBOL's still on the interstates. It's like they're paying IBM just tons. IBM makes so much money per year just keeping these COBOL places alive. Their products are so expensive, and they have really cool names. I like WebSphere. Process web pages with a COBOL application. It's sad, but hey, people are getting paid. All right, so these are these technologies. We could probably argue that ASP and JSP have both mostly died, and PHP is the lone wolf here that has been supported by those third-party template engines, okay? Because MVC wasn't natively supported. So those are our embedded languages. Let's see, what would I even call this other? I want to say container languages, but that's not even right. Let's call these server-first languages, but that's not even a great description. Hopefully you'll get what I mean by explaining it rather than that phrase. So we have a couple of these. One is called a servlet. We have another one, well, actually servlets are probably these are probably the best example. This is also a Java technology, servlet. And these guys would run out of a special kind of web server called a servlet container that Sun Microsystems made. It was called Tomcat Jakarta. So they had a web server called Tomcat Jakarta, which would allow you to run servlets. And these guys were the API endpoints before we needed them. Okay, and if you're not sure what I mean by API endpoints, that'll make sense when we start talking about that stuff probably next class. But idea is that instead of calling something expecting to get a web page back, when you talk to a servlet, it didn't have to be coming from a web page. So this kind of existed during a time period where we started seeing that, oh, you know what? Sometimes we're going to have front ends talking to a web, let's say web server, although what ended up happening is they started calling these things web services. Okay, so we kind of fudged the name a little bit and say, okay, well, these are web services, and what do web services do? Well, they're a web-based server which services front-end interfaces, where a front-end interface could be a web browser or it could be something else. So this is during a period of time where we started thinking about this idea of having, let's say thinking about this idea of leveraging the internet for having various applications speak to a server behind the scenes. Okay, this is before smartphones and things like this, but it's during the point in time where we start having applications that are internet aware. Email clients, for example. That's actually probably a kind of a bad example because email clients specifically talk to an IMAP or a POP server, so not a HTTP server. Come up with a better example. Well, I suppose there's plenty of good illegal examples. So how many of you have heard of something called Napster? Okay. File sharing, music sharing type stuff. Okay, so what these guys did is they wrote services that ran over port 80, ran over the HTTP protocol, because those are harder to block, and allowed illegal file sharing. I'm sure somebody probably shared something legal on Napster at some point in time, but not very often is the punchline. But something that was a big thing back then and still happens today is a lot of these network sharing type tools attempt to use port 80, which is the default web port on a network, because it's harder to block that. If you're going to block port 80, you have to block the web. You have to block web browsers. And that's difficult to do. So now you've added, this kind of gets over into the IT side of things. You've had to add a whole nother layer of security, where now you have to specifically pick apart the input streams to see what's legitimate traffic and what's illegitimate traffic dressed like legitimate traffic. Make sense? So this is kind of the world we live in. But this was kind of during a time where this idea of having programs running on a web server somewhere that served more than just spitting out web pages started becoming a thing. So it's really when people started considering the internet as a means for data moving between things, not just data moving to web browsers. All right, so we kind of saw the growing pains, if you will, of really what we view the internet as today. We don't view the internet as just the web browser. In fact, the web browser is probably, especially with apps and things like that today, web browsers are maybe not even our primary place we go to for web-based entertainment, right? I mean, Facebook would be another example of something that uses a web service. So when you open up Facebook and it's grabbing the news feed, it's having to go request that from somewhere and then bring that information in to show it on the screen. Now, some of us probably still use Facebook on a web browser or something like that, but at least some of the time we're digesting Facebook through a mobile app, right? So those are other examples. So that's where these web service things come from. So this idea of a servlet came up during that point in time where it's like, how can we take our, this is really during the time when Java was trying to be popular and failing. So Sun Microsystems kind of bet the farm on the Java programming language to the point where they even changed their ticker symbol on the New York Stock Exchange to be Java, J-A-V-A. Then they failed, basically. Oracle bought them because they were, they sort of failed as a company. Before that, they were a hardware and software company, mostly hardware. Sun Microsystems made computers and microprocessors, Spark chips. But they were trying to leverage Java as a tool for the masses, when Java was great at certain things, but was not the best tool for the job for most of the things they were trying to force it to be the best tool for the job for. Java's just slow. In my view, Java is one of my favorite languages, but I think Java's greatest contribution is to education, because it's one language that will run on everybody's machine. I don't have to worry about my students having a Mac or a PC or a Linux box. They can do their Java development on any of those machines. It's great. Okay. Well, so that's nice about Java. It's also very similar to C++ and C# and these languages. So you learn one, like I said earlier, programming as a skill set is something that is what's important, and you can learn any of these technologies pretty easily once you have programming as a skill set. Well, so having said that, this idea of a Java servlet was probably about a decade ahead of its time. So kind of came out. It's like, well, we're going to allow you to have a full-fledged application running on the server that's not just spitting out HTML and JavaScript. It could if you wanted it to. But now we're going to let you basically return anything you want. For example, XML or JSON. The problem is that XML and JSON didn't exist yet. Okay, so this is chicken, cart before the horse. Is that what they say? Yeah, that stuff. So kind of fell to the wayside. It actually still exists today, servlets. Google was a big adopter of Java, probably one of the big reasons why Java didn't fail directly and still is around today. But Google still uses servlets inside of their product, Google App Engine, okay, which is a cloud-based computing platform that acts as a web service, not necessarily for serving web pages, but for serving data to interfaces. That interface could be an iPhone app, could be an Android app, could be a web page, could be a watch, could be a toaster. We don't know, but interfaces somewhere. Okay, so that's a couple of back-end technologies. Here's our JavaScript buzzwords. So that whole segue there came from this last question of what is Node.js? All right. So the punchline here is we just spent the last, half hour talking about front-end technology. But now we're back to the question we were trying to answer about back-end technology. And we see JavaScript sitting here again. For the first time, we're seeing JavaScript associated with a back-end technology. What's the advantage of having JavaScript as a back-end language? Are there any positives to that? What do you think? You guys look so tired. You're tired? Really? See, the problem is because I'm so muted right now. My energy levels are low. See, some of these folks haven't had me before. You don't realize how muted this is. At least none of you have fallen asleep yet. I always find it funny when students fall asleep in the front row. What question did I ask? Oh, JavaScript. What's the advantage? What's the advantage of JavaScript in the back end? If you've been a front-end web developer, okay, so we've already kind of talked about this idea, this difference between front-end or client-side and back-end or server-side. Those are two different skill sets, right? Okay. Front-end is the skill set of making things look pretty, delivering end-user experiences, and then some dynamic stuff that we're delivering through JavaScript. Okay, so we would call a front-end developer primarily a design-based developer. Now, that doesn't mean they're a graphics person, okay? Because in order to do front-end development, you have to be able to do HTML and CSS stuff, and this is not a Photoshop skill set. Okay, so HTML and CSS, to be honest with you, and we're going to actually see it in here because we are going to do a front-end stuff. I'm familiar with a lot of technologies. And probably my least favorite thing to do is build web front ends. I don't think it's any fun. It's hard for me to do. It's hard to make good looking web front ends. So people who have that skill set, these aren't stupid people. These are people who have a very specialized skill set. Okay? Fine, they can't program like I can on the back end, but I can't write the user interface like they can on the front end. They have a mastery of HTML and how different browsers interpret different ways, because you have 3 different browsers that make your page look 3 different ways. Okay, so that's a hard skill set on that side. So these are folks that have lived on the front end and had to become domain experts over on that side of things. Okay, so we don't want to take anything away from them, but they've lived on the front end side. So their only programming language they've wielded, only true programming language they've wielded is JavaScript. Everything else has been a data representation language, namely HTML, CSS, that kind of stuff. And then they probably have some reasonable Photoshop skills. Okay, and it really depends on how they came to be a front end developer. Were they a designer first? If they were a designer first who then learned to do front end, they're probably a pretty good artist who then learned the HTML skill set. On the flip side, they might have been somebody who kind of, for lack of a better phrase, maybe failed out of software development and got into kind of web development. And there's plenty of tools there. And I think web development, maybe just as much so, if not more so, is an experiential thing, because it's easy. Something I talk about in my programming classes is you can academically learn how to do something software development wise. Okay, and you're going to say you haven't had any programming experience, so you're going to run into this. Is as we start doing some of this stuff, you're going to understand what we're doing, and then you're going to try to do it yourself, and you're going to, what the hell? Why doesn't this work? It's because there's a so do you play any sports? What sports do you? What sport? Cricket. Oh, favorite sport. I love cricket. Love cricket. My favorite made-up sport. I always give my grad students a hard time. They're primarily in the MSIT program. I only teach the programming classes over there. But pretty high number of our students are Indian, Pakistani, Saudi. So I mean, these countries, they're very big fans of cricket. So they're always talking about the Cricket World Championships. And so one of these years, I went and watched like the World Championship game. I don't remember. I think it was India versus, it was like 2 years ago, Sri Lanka or something like that. Does that sound right? Yeah, well, whatever. So something like, I'm not even kidding. So I'm watching, I'm truly trying to understand this game, okay? So somebody hits the thing, and then there's cheering. So I assume that's the team that won. No, they lost. I truly believe they were just happy it was over. Don't these games last like a week?
5 days.
5 days.
A test is going to last for 5 days. A ODI for 6 hours, and a T20 for 3 hours.
There are different types of
Cricket styles.
Different
Man, why can't it just be like American boxing? Match has been decided way before they stepped in the ring. Okay, so let's take soccer as an example. So, you decent soccer player? Okay, so I mean, I'm actually a great soccer player, mostly because of foot speed. You don't believe I'm fast? This is like a fat joke? All right. See, I got you guys woken up a little bit, right? All right. So you're a soccer player. So, I know a little bit about soccer. So, I mean, I wouldn't be a complete idiot out there, but you're going to know how to do things that I can't do. Like, you watch these guys on TV, they're dribbling the ball down the soccer pitch, right? Okay, down the pitch. And it's like they're not even thinking about it. Where, I'm going to have to think about what I'm doing. I'll be tripping over the ball sometimes and that kind of stuff. And, these players, they kick with different sides of their foot depending on what kind of spin they want to put on and stuff like that. You could academically teach somebody how to do something, but there's a difference between understanding what to do and actually doing it when you have to do it, right? Those are the difference there is practice. All right, so that's going to be the struggle with learning programming. So keep that in mind as you get frustrated doing some of the stuff, because you're going to be like, okay, well, it looks so easy when they did it in class, but it's not going to translate into that necessarily. So kind of what I was getting at with the front end web designer stuff, maybe even more so with that, is there are aspects of front end HTML molding, let's say, that has less to do about logic and more to do with your experience on how certain browsers handle certain things. So it isn't even an academic knowledge. It's legitimately experience-based. Okay, maybe more so than anything else that we deal with. I usually have this muted. Maybe more so than anything else with our programming-esque type of technologies. So in any case, these are folks that have been wielding JavaScript as their primary programming sword, if you will, for their whole career. And maybe rarely went over to the back-end side, because there's always been somebody else over there to handle that, some developer, because the learning curve to jump over there, they're doing very different things on the back-end side. The front-end side, the type stuff you're typically doing is like form validation. You know, did they put in their username and password before let's check it locally here on the web page before we actually request them to check the username and password credentials on the server. You know, let's not waste the server's time if they didn't finish filling out the form. Okay, so that's a lot of the stuff they're doing on the front end type thing. Similarly, some of this Ajax and jQuery stuff is going to be on the front end where it's like, okay, well, just this one little part, we want the sports score to refresh every 3 seconds, something like that. So we're going to have that one guy dial back. So that's a little logic call there, but you know, it's a very small little widget piece to it. There's a different mentality on the server side of things. Not harder or easier, it's just different. Okay? Well, up to this point, the server-side people were always wielding a different sword. PHP, or Ruby, or Python. Okay? Not that these folks couldn't have learned it, but it was intimidating to jump over there. Well, now, with Node.js, the back-end development language is the same language as those front-end people have been using on the front end forever. So now, whether it's easier or harder or whatever, it's at least there's a language constant that they're already familiar with. So there's a perception that there's a lower bar to jump over to the back-end side. So now, with Node.js as your back-end technology, you can leverage JavaScript for front-end stuff and back-end stuff. One language for both sides. Sounds like it could be a positive thing, right? Now, I would say generally speaking, it probably sounds like more of a positive than it actually is. Because like I'm saying, all these programming languages are the same, and at the end of the day, me saying they're the same is, I think, pretty accurate. But if you look at them, they actually look pretty similar. And they don't really look that foreign to each other. So they really are very similar to begin with. So I don't think that's as big of a benefit as maybe people make it out to be. But it certainly takes care of some of the intimidation factor, I guess. Now, what else does Node bring to the table? That's another important aspect of this. Node is clearly the newest of these. Remember I said I put these in this order. So Node is the newest of these technologies. So it brings a couple of things to the table. One thing is this idea of scalability. So Node.js handles thousands and thousands and thousands of hits much better than our other servers do. Not because Node.js is doing anything earth-shattering, but it's made a decision that previous servers did not. And this decision has to do with threads. All right, so how many of you have heard of threads before as it relates to technology? Okay, so a thread, we typically would say this is a lightweight process. So basically, this is a computer program that takes up less system resources than a typical computer program at the cost of a couple of other things. Because it uses less system resources, it also gets scheduled differently and some other operating system based things. But historically, what would happen is with an Apache or Ruby web server, every new incoming connection would translate into a brand new thread to manage the communication for that connection. Okay, so the idea here is it's when threads get spawned off, it's kind of like I like to think of it like a phone bank. If I'm sitting here waiting for the phone to ring, because people are calling in to let's take like the Jerry Lewis telethon, something like that. Okay, so the phone's waiting to ring, and we have a bunch of people who have volunteered to help with the event. The phone rings, I pick it up, and then I transfer the call over to one of the available helpers. Then I hang up the phone and wait for the next call. So this is blocking just for a second. As soon as the call comes in, I pick it up, I hand it off, listen for another phone call over and over and over again. Each time I pick it up and hand it off, that's spawning off a new thread. Okay? A little worker bee who's helping me do my work. That way I can sit here by the door, sit here by the phone, and wait for the next person who needs help to show up. So they're not left hanging. Okay? They're not left ringing the doorbell over and over and over and over again. Now, with that, these folks are benefiting because they're not having to wait. But what's ended up happening is this operating system, this computer that I'm living within, is getting its system resources used up. Because every single time a new connection comes in, I'm spawning off a thread. Historically, this was actually one of the most popular ways of trying to crash a web server. You've probably heard of something called a denial of service attack, DOS attack. So the way a denial of service attack would work is you would literally open up millions of simultaneous connections to like google.com. Every connection that came in would spawn off a thread. Also, Google has a lot of system resources, right? Probably Google's computer a little bit more powerful than my laptop here. Or their, array of computers. But it's still not infinite system resources, right? So places would get brought to their knees by having, denial of service attacks where you would have people opening millions of connections from all sorts of different places. That's a lot of viruses were written for this because what could happen is, let's say somebody decided to do a denial of service attack on Concordia. And we decided to do it from our dorm room, let's say, here at Concordia. Well, if Curcio here decided, okay, well, I'm going to attack Concordia, and he writes a little program that just puts an infinite loop and just keeps opening up socket connections to Concordia, they're going to, after maybe about 15 or 16,000 connections from the same IP address, they're just going to block that IP address. Okay? Little fly. No big deal, right? Because he was a lot of buzz coming from one place. It's easy to block one place. So what virus writers would do is they would put viruses out there that looked benign. They wouldn't do anything bad to your computer. Instead, what they would do is they would use your computer to attack somebody else's computer. So now you have a virus floating out in the internet. So you have 20 million computers infected with this virus, all individually attacking Google, for example. So now you have Google getting hit by 10, 15, 20, 30,000 different incoming connections from 10 million different independent computers. Hard to block 10 million computers. Make sense? So that's how these denial of service things work. And they work by basically starving out the servers. Even though Google has tons and tons and tons of system resources, that's not infinite. Eventually they run out of memory, they run out of processing power, they run out of hard drive space, whatever. They run out of something. And they have to shut down to stop the attack. Okay, so the problem with threads is they become victims of something like that. Now, at the same time, the reason that threads exist in the first place is to give us the perception that more than one thing is happening at once. So this is going back to an argument we had earlier tonight, dealing with technology kind of outpacing or technology and the problems we're trying to solve kind of working in tandem over the years. Why do new technologies come out? Well, threads initially were invented to solve the problem of having full processes, full computer applications that used up extra system resources being utilized to solve a smaller problem. And that smaller problem is how do I have my computer act like it's doing more than one thing at once? Make sense? Because back then we only had single core computers with one processor in them. It could only do one thing at once. Well, fine. How do I make it act like it's doing more than one thing at once? Because while I'm doing this, all these little tiny CPU cycles that I'm not currently using, because my computer's still pretty fast, I'd like them to be utilized to do something else, to be productive. That's where threads came from. Well, now we're in a world where we have plenty of CPU resources. We can have 4, 5, 6, 7, 8 things happen simultaneously, even more in some of our big servers. That could physically happen simultaneously, not pretend to happen simultaneously. And then on top of that, we have all these threads. Now it's easy to take advantage of that thing that was built to fix an old problem. So what Nodejs does is they kind of change our mentality on this. Instead of relying on threads to handle multiple users, Nodejs has made the assumption that, okay, our computers today are pretty fast. And because they're so fast, what we can do is we can rely on them being able to keep up with the load by solving the problems very quickly. So Node.js does not spawn off a brand new thread for each incoming connection. Instead, it spawns off one thread for all math calculations and a second thread for all I/O operations. And I/O operations are then handled on a first-come, first-served basis. Okay? Historically, we would have said, well, I/O could be expensive. So we don't really want... I don't want to have to wait for him to finish putting in his ATM PIN code, when he's forgotten and he screwed it up because he's got fat fingers, right? Screwed it up 30 times in a row. Why should I have to wait? Real life says that I'd rather have a second ATM machine that I could walk up to. Okay? Well, the reality is with Node, you're only allowed to get in line when you're actually ready to do your I/O. That means he has remembered his code. And the thing is that thread, that single I/O thread on Node is going to be able to serve that person who wants to do I/O way, way, way faster than he could punch in a code on an ATM machine. Our computers today are really fast. And Node leverages that. Says, you know what? Those 30 people who are currently waiting for I/O stuff, they're not even going to notice. Because each of those I/O requests are going to get handled so quickly that nobody's going to be the wiser. And what are we benefiting? We're using less system resources and we're opening ourselves up to less of an attack. Make sense? Okay, so Node is very scalable because it allows us to leverage computation power, which we have an abundance of. Historically, computation power was a problem, right? So we go back to the early days of the internet. So let's just say that the internet really kind of became popular in, it's in 95, 94, 96, somewhere in that ballpark, right? Mid-90s is when the internet was kind of a, more than just a thing. People knew it was out there and was starting to become popular. Our computers are a little quicker today than they were back then. Our internet speeds are a little bit quicker. The speeds we complain about today on the internet, people would have killed for back then. People paid thousands of dollars a month back then for speeds that we spit on today and say this is unusable. um, and I always find it funny. They reference it in movies and stuff like that. You've heard in different movies or TV shows, people reference like a T1 connection. Man, wouldn't it be awesome if we had a T1 connection directly into our house? People used to pay like $30,000, $40,000 a month for a dedicated T1 to their house. Sounds cool, right? Sounds like it would be good. A T1 is only 1.44 megabit per second. That's the budget pleaser DSL on a bad day. People pay 30 grand a month for that back then. So, people who couldn't afford that, well, they would get fractional T1s. So they get a fraction of that and pay a ridiculous amount of money for it. 56K modems, people used to drool over. So, I mean, we have to look at our technology today through the right lens, because it does drive some of our decision making. It's easy for us to fall prey to this idea that, we've done it this way for the last 15 years, so shouldn't we keep doing it this way? At some point, we need to change our mind. So Node kind of has turned that corner and said, you know what, computers are faster. We have more system resources than we need. Computers are faster than they've ever been. We should kind of rely on that rather than wasting our system resources on things that we don't need them for. Okay. So questions about any of that stuff? So we have 2 things that we need to do for next week. We have 4 contenders for our server-side technology. So we go back to this slide right here. Okay, we have 4 contenders for this guy. That's who we're fighting for. Okay, and that guy needs to serve our web front ends, and at the very least support our phone front ends. Okay, so we need to do some research. Let me open up Blackboard here. Did I not make an assignments folder yet? I'll go ahead and make one. Okay, so you actually have 3 assignments due for next week. Most of them are small ones, though. So we'll talk about it. One of them is a big one, but you have a week to work on it. First one's already up. I need you to visit cuwcs.slack.com. We use here on campus a chat program called Slack. If you've never used it before, it's pretty good. And what you need to do is you need to join our Slack channel. Sign up using your cuw.edu email. I'll tell you how to do it on the in the instructions. Then ultimately either go through their webpage, get the Mac app, get the Windows app, get your phone, iPhone, Android app. There's apps for all of these different things. Go in, join the 518 channel. So come in here and post like what these guys did here. What your name is and what you did over break. Basically just proving to me that you have access to this, because I'll be putting announcements and stuff like that up on here. Okay? And then what you need to do is you need to turn in a screenshot of this as the submission thing for that assignment. All right? It will take you less than 3 minutes. All right? So don't not do that one and then complain like, oh, I didn't get to it. Okay? Because I'll laugh. That's what will happen. All right, so that's assignment 1. Due next week. Then we have assignment 2 is not actually going to be something you submit, but it's something I do want you to prepare for next week because I want to spend some time talking about it. I mentioned we would probably talk about the second half today, but then we got carried away. So what I want you to do is, based on what we've talked about today, start thinking about a project similar to what we've talked about in class today. Doesn't have to be the same thing. well, shouldn't be the same thing. It doesn't have to be super similar. It could be very similar. You know, if you don't want to deviate too much and you just want to, like, okay, well, I want to stick to the road, so anything we do in class is very directly applicable to what we do at home, that's fine. Okay, I want you to have a good experience in here, because one of the things we're trying to get out of this class is obviously we're trying to build something real, but it's less about having that skill set to be able to sit down and build something real from scratch, more about, especially for the IT people in here, more about having an appreciation of that process. You know, what are the pieces that go into a full software development product? Okay, because it's not just web, it's not just iPhone, it's not just database, it's not just web server, it's not just third-party APIs pulling information in, it's not just payment processing, it's all those things, and how do we get them to connect together? That's the real problem, right? How do we solve for those different pieces? So come prepared next class to discuss at least the start for your idea. Okay, and then what we'll do is we'll spend some time at the beginning of class next time talking through it so we can maybe evolve those ideas. If something kind of, you know, maybe you'll come up with an idea and somebody says, oh, well, wouldn't it be cool if you did this? Or something like that. That'll allow you to evolve that idea. Because what we want to do is we want to get everybody's mind wrapped around their ideas here within the first, couple of weeks. Because before long, we're going to be actually off to the races writing this stuff. Okay? In the meantime, especially for you, since you haven't had programming before, start working through some of those other videos. And then when we actually get to some of the assignments, we can do some, I can help you with some of the stuff. Because, like I said, I want you to have a good experience. Okay? Because the guys who are doing this for a Masters of CS, they're supposed to get more out of this. You're supposed to get what you would get out of 535 and 537. And frankly, you've almost gotten what you would get out of those classes in today's lecture. You'd have obviously more programming stuff, but in terms of content, we covered a lot of stuff in 4 hours today that you wouldn't cover in an MSIT class. All right, so come prepared to discuss that. There won't be anything to submit, but I'll put you on the spot and say, okay, tell me about your idea. So if you just say, okay, I don't know what you're talking about, then somebody's going to get punched. I'm not allowed to touch students, but I got guys. He's a wrestler back there, right? Yeah, see? And old Alex, he's old Alex. Do you guys know old Alex? Old Alex used to be a nursing student here. Then he switched to computer science, and now he's this. All right, so let's talk about our real homework assignment. What did you say? All right, so homework number 2. So this is going to be to research these 4 technologies. So research PHP on Apache, Ruby on Rails, Python on Flask, and Node.js in the context of the application we discussed in class, and write a 3 to 5 page paper arguing for one of the 4 technologies. That is to say, which technology should we pick for our project and why? Okay, important things to consider here. First of all, while this is not an English class, I do want these to be reasonably well written. I'm not going to sit there and nitpick about grammar, but especially for students who are English isn't your first language, it should not read like broken English. Okay, so we have a resource center here on campus. We have a writing center. Take your paper in there. They'll read it. They'll say, this is what's wrong with it, and they'll fix it. They'll help you fix it, okay? That's going to save you 20% on this paper. Okay, so take advantage of that. I can't stress that enough. It's a thing. If you're going to come over here and go to school, and you're in the middle of Wisconsin, you got just be able to write in English. I wouldn't go over to one of these other countries and write in anything. I write my same bad English. is what I would do. All right, so take advantage of that. It also gets submitted through. It automatically gets submitted through like a whatever cheating thing. So don't copy directly off the web. I do realize that there are some things, especially with technical arguments, that it's going to be beneficial to cut and paste some stuff. At the very least, try to rephrase things or something like that. I mean, I'm not going to be super nitpicky about it. So I don't want to be a jerk about it is what I'm saying. But, prove to me that you've at least read the material and gave me, and I'm reading your thoughts as opposed to, copy and paste from Wikipedia or something like that. Make sense? All right. So I'm looking for you to argue for one of these 4 technologies for the one we should use. There are no wrong answers to this, okay? As long as you support your wrong answers with reasonable arguments. Okay, you might say, I think we should use this because of this, this, and this, and those 3 arguments might be very good arguments. And what we talk about in class next time might reveal a 4th thing maybe that you didn't consider that does disqualify your points, but that doesn't mean the points you made are bad points. Does that make sense? So I'm asking you to consider what you are able to consider in light of these technologies and give me a recommendation. Okay, so don't worry if you talk to your friend and he recommended Ruby and somebody else recommended PHP. You both could be right. Okay, those could both be perfect papers. All right, at the end of the day, I already know what we're picking. so unless you talk me out of it, is the punchline. Okay, so let's see. So that makes sense what I'm asking you to do there. So the Slack thing, do that as soon as you get home or wake up tomorrow morning, whatever. Start working on this paper. If you have questions, you should be able to write stuff on Slack. Ask me questions, things like that. Having problems finding resources, I'm happy to try to help with that as well. Same time, same station next week. And make sure you get your paper submitted on here prior to the beginning of class because it'll time out and give you a bad grade or something. I don't know what it does, but it does bad things. Okay, I will see everybody next week.
Oh,